The Internet is the global system of interconnected computer networks that use the Internet Protocol Suite to link billions of devices worldwide. It is a network of networks that consists of millions of private, public, academic, business, and government networks of local to global scope, linked by a broad array of electronic, wireless, and optical networking technologies. The Internet carries an extensive range of information resources and services, such as the interlinked hypertext documents and applications of the World Wide Web, electronic mail, telephony, and peer-to-peer networks for file sharing. Although the Internet Protocol Suite has been widely used by academia and the military-industrial complex since the early 1980s, events of the late 1980s and 1990s, such as more powerful and affordable computers, the advent of fiber optics, the popularization of HTTP and the web browser, and a push towards opening the technology to commerce eventually incorporated its services and technologies into virtually every aspect of contemporary life. The impact of the Internet has been so immense that it has been referred to as the eighth continent. The origins of the Internet date back to research and development commissioned by the United States government, the government of the UK and France in the 1960s to build robust, fault-tolerant communication via computer networks. This work led to the primary precursor networks, the ARPANET, in the United States, the Mark Chapter 1 NPL network in the United Kingdom and Cyclades in France. The interconnection of regional academic networks in the 1980s marks the beginning of the transmission to the modern Internet. From the late 1980s onward, the network experienced sustained exponential growth as generations of institutional, personal, and mobile computers were connected to it. Internet use grew rapidly in the West from the mid-1990s and from the late 1990s in the developing world. In the 20 years since 1995, Internet use has grown 100 times, measured for the period of 1 year, to over one-third of the world population. Most traditional communications media, including telephony and television, are being reshaped or redefined by the Internet, giving birth to new services such as Internet telephony and Internet television, newspaper, book, and other print publishing, or adapting to website technology, or are reshaped into blogging and web feeds. The entertainment industry was initially the fastest growing segment on the Internet. The Internet has enabled and accelerated new forms of personal interactions through instant messaging, Internet forums, and social networking. Online shopping has grown exponentially both for major retailers and small artisans and traders. Business-to-business and financial services on the Internet affect supply chains across entire industries. The Internet has no centralized governance in either technological implementation or policies for access and usage. Each constituent network sets its own policies. Only the overreaching definitions of the two principal namespaces in the Internet, the Internet Protocol Address Space and the Domain Name System, are directed by a maintainer organization, the Internet Corporation for Assigned Names and Numbers. The technical underpinning and standardization of the core protocols is an activity of the Internet Engineering Task Force, a non-profit organization of loosely affiliated international participants that anyone may associate with by contributing technical expertise. Terminology. The term Internet, when used to refer to the specific global system of interconnected Internet protocol networks, is a proper noun and may be written with an initial capital letter. In common use and the media it is often not capitalized, viz. the Internet. Some guides specify that the word should be capitalized when used as a noun, but not capitalized when used as an adjective. The Internet is also often referred to as the net, as a short form of network. Historically, as early as 1849, the word interneted was used uncapitalized as an adjective, meaning interconnected or interwoven. The designers of early computer networks used Internet both as a noun and as a verb in shorthand form of internetwork or internetworking, meaning interconnecting computer networks. The terms Internet and World Wide Web are often used interchangeably in everyday speech. It is common to speak of going on the Internet when invoking a web browser to view web pages. However, the World Wide Web or the web is only one of a large number of Internet services. The web is a collection of interconnected documents and other web resources, linked by hyperlinks and URLs. As another point of comparison, Hypertext Transfer Protocol, or HTTP, is the language used on the web for information transfer. Yet it is just one of many languages or protocols that can be used for communication on the Internet. The term interweb is a portmanteau of Internet and World Wide Web, typically used sarcastically to parody a technically unsavvy user. History. Research into packet switching started in the early 1960s, and packet-switched networks such as Mark I at NPL in the UK, ARPANET, Cyclades, Merit Network, Timnet, and Telenet were developed in the late 1960s and early 1970s using a variety of protocols. The ARPANET in particular led to the development of protocols for internetworking, where multiple separate networks could be joined together into a network of networks. The first two nodes of what would become the ARPANET were interconnected between Leonard Kleinrock's Network Measurement Center at the University of California, Los Angeles Henry Samuel School of Engineering and Applied Science and Douglas Engelbart's NLS system at SRI International in Menlo Park, California, on 29 October 1969. The third site on the ARPANET was the Color-Fried Interactive Mathematics Center at the University of California, Santa Barbara, and the fourth was the University of Utah Graphics Department. In an early sign of future growth, there were already 15 sites connected to the young ARPANET by the end of 1971. These early years were documented in the 1972 film Computer Networks, The Heralds of Resource Sharing. Early international collaborations on the ARPANET were rare. European developers were concerned with developing the X25 networks. Notable exceptions were the Norwegian seismic array in June 1973, followed in 1973 by Sweden with satellite links to the Tannum Earth Station, and Peter T. Kirstein's research group in the United Kingdom, initially at the Institute of Computer Science, University of London, and later at University College London. In December 1974, RFC 675 Specification of Internet Transmission Control Program by Vinton Cerf, Joe Gendel, and Carl Sunshine used the term Internet as a shorthand for internetworking, and later RFCs repeated this use. Access to the ARPANET was expanded in 1981 when the National Science Foundation funded the Computer Science Network. In 1982, the Internet Protocol Suite was standardized, which permitted worldwide proliferation of interconnected networks. TCP/IP network access expanded again in 1986 when the National Science Foundation Network provided access to supercomputer sites in the United States from research and education organizations. First at 56 kbit per second and later at 1.5 mbit per second and 45 mbit per second. Commercial Internet service providers began to emerge in the late 1980s and early 1990s. The ARPANET was decommissioned in 1990. The Internet was fully commercialized in the U.S. by 1995 when NSFNET was decommissioned, removing the last restrictions on the use of the Internet to carry commercial traffic. The Internet rapidly expanded in Europe and Australia in the mid to late 1980s and to Asia in the late 1980s and early 1990s. The beginning of dedicated transatlantic communication between the NSFNET and networks in Europe began a low-speed satellite relay between Princeton University and Stockholm, Sweden in December of 1988. Although other network protocols such as UUCP had global reach well before this time, this marked the beginning of the Internet proper, as an intercontinental network. Slightly over a year later, in March 1990, the first high-speed T1 link between the NSFNET and Europe was installed between Cornell University and CERN, allowing much more robust communications than were capable with satellites. 6 months later, Tim Berners-Lee would begin writing World Wide Web, the first web browser, after 2 years of lobbying CERN management. Since 1995, the Internet has tremendously impacted culture and commerce, including the rise of near-instant communication by email, instant messaging, telephony, two-way interactive video calls, and the World Wide Web with its discussion forums, blogs, social networking, and online shopping sites. Increasing amounts of data are transmitted at higher and higher speeds over fiber optic networks operating at 1 Gbit per second, 10 Gbit per second, or more. The Internet continues to grow, driven by ever greater amounts of online information and knowledge, commerce, entertainment and social networking. During the late 1990s, it was estimated that traffic on the public Internet grew by 100% per year, while the mean annual growth in the number of Internet users was thought to be between 20% and 50%. This growth is often attributed to the lack of central administration, which allows organic growth of the network, as well as the non-proprietary nature of the Internet protocols, which encourages vendor interoperability and prevents any one company from exerting too much control over the network. As of the 31st of March 2011, the estimated total number of Internet users was 2.095 billion. It is estimated that in 1993 the Internet carried only 1% of the information flowing through two-way telecommunication. By 2000 this figure had grown to 51%, and by 2007 more than 97% of all telecommunicated information was carried over the Internet. Governance. The Internet is a global network comprising many voluntarily interconnected autonomous networks. It operates without a central governing body. The technical underpinning and standardization of the core protocols is an activity of the Internet Engineering Task Force, a non-profit organization of loosely affiliated international participants that anyone may associate with by contributing technical expertise. ICANN is governed by an international board of directors drawn from across the Internet technical, business, academic, and other non-commercial communities. ICANN coordinates the assignment of unique identifiers for use on the Internet, including domain names, Internet protocol addresses, application port numbers in the transport protocols, and many other parameters. Globally unified namespaces are essential for maintaining the global reach of the Internet. This role of ICANN distinguishes it as perhaps the only central coordinating body for the global Internet. Regional Internet registries allocate IP addresses. African Network Information Center for Africa, American Registry for Internet Numbers for North America, Asia-Pacific Network Information Center for Asia and the Pacific region, Latin American and Caribbean Internet Addresses Registry for Latin America and the Caribbean region, RACO IP Europeance, Network Coordination Center for Europe, the Middle East, and Central Asia. The National Telecommunications and Information Administration, an agency of the United States Department of Commerce, continues to have final approval over changes to the DNS root zone. The Internet Society was founded in 1992 with a mission to assure the open development, evolution and use of the Internet for the benefit of all people throughout the world. Its members include individuals as well as corporations, organizations, governments, and universities. Among other activities, ISOC provides an administrative home for a number of less formally organized groups that are involved in developing and managing the Internet, including the Internet Engineering Task Force, Internet Architecture Board, Internet Engineering Steering Group, Internet Research Task Force, and Internet Research Steering Group. On 16 November 2005, the United Nations-sponsored World Summit on the Information Society in Tunis established the Internet Governance Forum to discuss Internet-related issues. Infrastructure. The communications infrastructure of the Internet consists of its hardware components and a system of software layers that control various aspects of the architecture. Routing and service tiers. Internet service providers establish the worldwide connectivity between individual networks at various levels of scope. End users who only access the Internet when needed to perform a function or obtain information, represent the bottom of the routing hierarchy. At the top of the routing hierarchy are the Tier 1 networks, large telecommunication companies that exchange traffic directly with each other via peering agreements. Tier 2 and lower-level networks buy Internet transit from other providers to reach at least some parties on the global Internet, though they may also engage in peering. An ISP may use a single upstream provider for connectivity, or implement multi-homing to achieve redundancy and load balancing. Internet exchange points are major traffic exchanges with physical connections to multiple ISPs. Large organizations, such as academic institutions, large enterprises, and governments, may perform the same function as ISPs, engaging in peering and purchasing transit on behalf of their internal networks. Research networks tend to interconnect with large sub-networks such as GEANT, GLORIAD, Internet2, and the UK's National Research and Education Network, JANET. It has been determined that both the Internet IP routing structure and hypertext links of the World Wide Web are examples of scale-free networks. Computers and routers use routing tables in their operating system to direct IP packets to the next hop router or destination. Routing tables are maintained by manual configuration or automatically by routing protocols. End nodes typically use a default route that points toward an ISP providing transit, while ISP routers use the Border Gateway Protocol to establish the most efficient routing across the complex connections of the global Internet. Access. Common methods of Internet access by users include dial-up with a computer modem via telephone circuits, broadband over coaxial cable, fiber optic or copper wires, Wi-Fi, satellite and cellular telephone technology. The Internet may often be accessed from computers in libraries and Internet cafes. Internet access points exist in many public places such as airport halls and coffee shops. Various terms are used, such as public Internet kiosk, public access terminal, and web payphone. Many hotels also have public terminals, though these are usually fee-based. These terminals are widely accessed for various usage, such as ticket booking, bank deposit, or online payment. Wi-Fi provides wireless access to the Internet via local computer networks. Hotspots providing such access include Wi-Fi cafes, where users need to bring their own wireless devices such as a laptop or PDA. These services may be free to all, free to customers only, or fee-based. Grassroots efforts have led to wireless community networks. Commercial Wi-Fi services covering large city areas are in place in London, Vienna, Toronto, San Francisco, Philadelphia, Chicago, and Pittsburgh. The Internet can then be accessed from such places as a park bench. Apart from Wi-Fi, there have been experiments with proprietary mobile wireless networks like Ricochet, various high-speed data services over cellular phone networks, and fixed wireless services. High-end mobile phones such as smartphones in general come with Internet access through the phone network. Web browsers such as Opera are available on these advanced handsets, which can also run a wide variety of other Internet software. More mobile phones have Internet access than PCs, though this is not as widely used. An Internet access provider and protocol matrix differentiates the methods used to get online. Structural. Many computer scientists describe the Internet as a prime example of a large-scale, highly engineered, yet highly complex system. The structure was found to be highly robust to random failures, yet very vulnerable to intentional attacks. The Internet structure and its usage characteristics have been studied extensively, and the possibility of developing alternative structures has been investigated.